Hello. So in this lesson, we will be looking at inverses. So some key notes about inverses is that an inverse or inverse relation is the reversed x and y values of an equation or a simple coordinate value. So here you have a regular simple coordinates or values, and then the reverse relation of this would be, you would just simply switch the x and the y values. So here you would have 0 and 4, and instead for the reverse relationship you would have 4 and 0. Just completely switched. So if this is not, if the original is a function, the inverse relation does not necessarily have to be also a function. If it is a function, which it is not here, because there's two values of x which has different values of y. If it is an inverse function, you would write it as f with an exponent, kind of an exponent of -1, but it would be called the inverse of f. That's what you would say if you saw this. So it would basically be, that means that this is just another way of saying that it's an inverse. So how you would find an inverse? First, you would change it to x and y notation. So if you had it in f of x, you would change it into x and y notation. Then you would switch x and y. You would switch x and y with y and x, and vice versa. Then you would solve for y, and if the new equation is an inverse or is a function, you would change it into inverse of x, f, x. So here are a couple of examples. I'm going to do each one like a linear, quadratic, and root function. A linear, the inverse of a linear is always going to be a function unless it is in a horizontal way in the beginning, and then it would turn into vertical, and a vertical function is not a function. So here you would have this, and then you would change it to xy notation, so y would be here. Then you would make x with y, you would switch those two over. Then you would use this elimination process to get y by itself. So you would, since there's +3 here, you would subtract 3 to both sides. And since there's a 4 and you're timesing it by 4, you're going to divide both sides by 4. And you're going to get your final equation to be like this. So I have two ways, it's just both ones are right. I also drew a quick graph just to show you that how it's flipped. So you have, always label your graphs. A quadratic function is basically the same thing. You would know it's quadratic because of the square root. The opposite of quadratic, so the inverse of a quadratic function would be a root function. So that's how you know the answer here. So you would basically switch over, subtract, you would change it to xy notation, change the x and the y, subtract 5. So you would add 5 to both sides. And here you would, since there's an exponent of 2, you would square root both sides. So here you have a square root, and then the brackets are out here. And you would, now you're trying to get rid of trying to get rid of 4. So since there's a +4, you would subtract 4 to both sides, and you would get the equation of this. Root function, the opposite of a root function is a quadratic. So the inverse of a root function is a quadratic function. So here you would have the same. You would change it to xy notation only if it is in f of x form. You would change it to x and y, and then since there's a first you would take away the 6, going opposite of order of operations, BEDMAS, going working opposite direction of it. So here so you have +6, you would subtract 6 to both sides. Here you have a 2, so you would divide 2 by both sides, and you could also, this is another way of writing it, to get rid of the square root over here. I'm sorry I'm going really fast, but to get rid of the square root over here, you would square the thing by square the other part by 2, and then you would eliminate this -3 by adding 3 to both sides, and this would be your root function equation. Also for inverses, the domain and ranges are switched. Just remember, so the x would be the y and the y would be the x. So, sorry I went really fast, but I hope you got what you needed, and good luck on your test. Thank you. Thank you for watching.